Here we have a a circuit with three different resistors, and two different batteries. So let's have a look at this. We're being asked to find the current through each resistor. It's a fairly common question about circuits kind of question. And we're also asked to find all potential values in the circuit and then some potential differences between points. These are skills that I want you to have. So let's start the way that I've been hoping that we will every time, and that is by labeling as many potential values in the circuit as we can, just on inspection from first looking at the circuit. So I look at the circuit and I see that there are these two batteries here, the 4E battery is larger. So there's no one decision, but for a simple circuit like this, I would probably choose the bottom of the 4E battery. So that means the negative terminal. Every battery, I sometimes talk about a battery as having a low side and a high side. And I'm talking there about potential elevation, right? The positive terminal of the battery is always the high potential. The negative terminal is always the low potential. So I think about those as the high and low for the battery. So I'll go through and highlight first, and then we can, how about then we talk about values. So I'm just going to right now just pick some different colors here and highlight my different sections. I can do that always with the circuit just by looking at the components there. I've got this kind of T-shaped piece in here, and then I have this corner here. Okay, now I'm going to go in and label those. So this here at point A, that's one that I would say, all right, I call that 0, or I can call that my 0 elevation, and then I measure from there. And if I was wrong about that being a 0 and there's a lower one, again, the worst that can happen is I get a negative value. So there's like a basement to the building. In other words, you could think about it that way. So anyway, I go from blue to yellow. When I do that, I'm stepping up 4E. So I know in yellow, I'm now at the elevation 4E. And if I turn the corner at point B and start traversing down that wire, I don't know the current in that 3R resistor, so I can't label the red. So I'm just not going to go that way. I'm going to continue going over to the 2E battery where I cross from yellow to green across that battery because that's a known step, right? It's 2E. So the yellow is 4E. I drop down 2E. That means at the green, that elevation there is 2E. All right, so what I know about the pink is that it's greater than 0 and it's less than 2E, right? I can know that about it, but I need to do some more on this circuit. I need to figure out some more stuff in order to find out what's going on with it. So just notice that sometimes you can get a bunch of information on inspection by doing potential analysis, but then you might have to move forward with a different method. So let's just use Kirchhoff here. This is a nice little circuit to use that for. I'll start by doing the left loop. I like to keep track of what I'm doing instead of just writing out equations. If I just write out equations without keeping track, sometimes it's hard for me to check my signs. So I'll go the left loop clockwise here, and I'll start from point A and go around clockwise. So the first thing I hit is that battery, and I hit it from low to high. So that's going to be a positive 4E. And then again, I'm doing the left loop clockwise starting at point A. So I go up, step up through the battery, and then I step down through my 3R resistor. And now I realize, oh, I don't have my currents in, so I can't actually use Kirchhoff. So this is a good explanation of why if a student has Kirchhoff equations on like an exam or something, and they don't have their currents written in, I know they're just like making stuff up because you don't know what sign to use here unless you have your currents drawn in. So we have to draw those in. So I would say this is the 4E battery. So what might make sense here is drawing that current. I'll call that I1. The 2E battery, I'm just going to go with the traditional direction through that battery there. That'll be my I2. And if those are both going into point B, I know that that would make this current flowing down. Again, this is Kirchhoff. It doesn't matter if I'm right, but I always try to choose something that seems like it has a chance of existing anyway. So 4E, we went through the 4E battery, we're coming down 3R, and then I3 is what I've called that current. And then we loop around right to left from red to blue through the 2R battery there. And I'm going with the current in both those cases. So 2R and current I1 is the current that goes through the 2R resistor. That brings me back to where I started. I've completed my loop. So there's an equation. Then I can do the right-hand loop, and I'll go clockwise for that one as well. I'll start at point B, say, and go clockwise. If I start at point B and go clockwise around the right-hand loop, the first thing I do is I step down at the 2E battery. So my first term here is actually negative. And then when I go through the R resistor clockwise from right to left, I'm going against the current. So that's actually adds, and that's I2. And then when I go up through the 3R resistor, I'm going against the current. So again, I'm stepping up here. So that's 3R, and the current that goes through the 3R resistor is I3. I'm back to where I started. I can say equals 0. That's my second equation. I have 3 currents, so I need 3 of 3 unknowns, right? I need 3 equations. I can then use a junction rule at one of the junctions here. So I don't know, I can look at junction B. So the currents going into junction B are I1 and I2, and the currents coming out of junction B are I3. So there I have my 3 equations. I can solve those algebraically. What I will get when I solve those equations is I1 is equal to 10E over 11R, I2 negative 2E over 11R. So I chose the wrong direction for I2. And I3, 8E over 11R. So those are my currents. And again, what I would notice about this one here is that with that sign there, is just I chose the wrong direction. And that'll probably, that's going to happen to you. And in a case like this, it's because the 4E battery is pushing current, the quote unquote wrong direction through the 2E battery. That's all that's going on. But remember with Kirchhoff that you don't have to have those directions right. Anyway, what this allows us to do is to find, say, the potential difference across the 2R resistor. I'm going to call that V sub 2 right there. So the potential difference across this 2R resistor is going to be equal to the current going through it, which is I1, which we now know, right, multiplied by its resistance, which is 2R. So that will be 10E over 11R times 2R. So 20E over 11. That's my V sub 2. So what that allows me to do then is to figure out that what the value of the red is. So if I'm at point A, I'm at 0. Then when I go through the 2R resistor, I'm stepping up to that pink color. Pink is a higher elevation. And my step is equal to 20E over 11. So this elevation there is equal to 20E over 11 as well. Okay. And then once you have that, then we have all of the elevations, the potential values, same thing, right? Elevations in the circuit. And you can find any of the potential differences that you want there. So the potential difference between, between A and B, you can read that right off the diagram, right? That's going to be, so if I say potential difference between A and B here, that's going to be the difference between 0 and 4E. So that's just the height difference between the two. The potential difference between B and C, again, the only thing that sits in between B and C, if you follow kind of that route, getting from B to C, is the 2E battery. So the difference there is just 2E. The difference between A and C. If I start at A, I'm at 0. C, I'm at 2E, so that difference is just 2E. Then they also ask us for the difference between B and D there. So B is higher, right? B is up at 4E, so that'll be 4E minus 20E over 11. And you could clean that up there, get common denominators. But you get my point. So skills that I want you to have that are important in this problem: the highlighting I was doing, labeling elevations, finding differences between potentials, and then use of Kirchhoff when you need it.